A map is a representation of a place. We may be quite familiar already with the type of map that shows the shape of a landscape using contours. This is a wooden model which illustrates this. We've got the dark wood representing the contours and the light wood representing the land surface. So we can see that the contours all stay at the same height, regardless of which way we look at the landscape. And those contours make some distinctive patterns. So we can see the gentle ground, the gentle slope here on the model, has the contours widely spaced apart. The steep side of this model has the contours very close together. The hilltops are shown by ring contours. And the valley here has a V shape in the contours with that V pointing uphill. These types of maps are very common. But as geologists, we need to think about geology on and how geology is represented on maps in a slightly different way. We do have the effect of the landscape, but we also need to think about the geology beneath the ground. This is another model. This model, through different colours of wood, shows us the geology of an area. The different colours of wood represent different types of rock. It has the same landscape as the contour model. But here we see different patterns shown by the different coloured woods. If we look at these patterns, we can start to interpret maybe what's going on underneath. Because although we see on the map the view from above, like you're seeing on this particular image at the moment, we do need to think as well about what's underneath the ground. So we think about a cross-sectional view, a slice through the ground so we can see what's underneath. But that has to be imaginary. It has to be something that we as geologists work out, rather than necessarily something we can see. Where that slice through the ground takes place will change what we can see. Because we'll see different features in the geology, perhaps with different slices or different cross-sections through the ground. The map, though, does have some distinctive patterns. It does have some distinctive things that we can work out. For example, we can start to work out cross-cutting relationships. We can recognise distinctive structures, such as these straight lines here representing dikes cutting through the rocks. We can start to establish the relative age of these dikes compared to other rocks that we see. We can find rocks that sit on top of others as an unconformity. We can start to work out some superposition from the evidence that we can see. So these patterns that are drawn on geological maps are a result of the interaction between the landscape and the geological structure underneath. Now, not all geology is as complex, perhaps, as that pattern we can see on this particular model. If we compare it with another model, where the geology is much simpler, we can still see some distinctive patterns. This particular pattern, this V shape across the valley, is as a result of the structure. So here we can see these rocks are dipping fairly steeply in the same direction that the valley goes down. The V shape that we get tells us which way these beds are dipping. They must be dipping in this direction because that's the way the V points. We can also then start to work out the relative age of these beds. If they're dipping in this direction, the thick bed here, thick dark bed, must be older than these thinner dark beds. If we look at that in a cross-section view, that's what we'll see. So geology maps have a set of distinctive patterns that allow us to work out the geology of an area, even the geology that we can't see, by looking at these recognizable patterns that we'll see where these rocks reach the surface.